In this video, we're going to talk about relating the rates of reaction. Because of the fact that we know from first semester the fact that all the amounts in the chemical reaction are related because of their stoichiometry, the 2, the 4, and the 1. In last semester, we would say the fact that 2 dinitrogen pentoxide molecules reacted to form 4 nitrogen dioxide molecules plus 1 oxygen, or that 2 moles of nitrogen pentoxide decomposed to form 4 moles of nitrogen dioxide plus 1 mole of oxygen. And so because of that, we can also relate the rates. So the rate of formation of oxygen is the change in oxygen concentration over the change in time. And the rate of decomposition for the dinitrogen pentoxide is negative because all reactants are negative, all products are positive. It's decreasing in concentration, so the change in the N2O5 over the change in time. Now, to relate these two, however, it's not 1-to-1. It's the change in oxygen is 1/2 of the change in N2O5 over change in time. And so where does the half come from? Is you take whatever stoichiometric reaction is there and you put it as the denominator there. Okay, so the coefficient here becomes the denominator there. All right, and so all the coefficients become the denominator of the fraction. So let's see how we apply that. So bacterial degradation of ammonia. The Nitrosomonas bacteria converts ammonia into nitrate in the presence of oxygen in the following reaction. 2 ammonias plus 3 oxygens goes to form 2 hydrogen ions plus 2 nitrite ions plus 2 waters. So how is the rate of formation of H plus and NO2 related to the rate of oxygen? And so I can relate any reactant or product here. Okay, so I'm looking at this one and this one and this one. Okay, so I'll go in the order that it says. Okay, so hydrogen, it's a product, so positive. And the 2 coefficient becomes 1/2. NO2, it's a product, which means it's positive. And again, the 2 becomes a 1/2. For the O2, it's a reactant. So therefore, it's going to be negative. And it becomes 1/3 because of the 3 there. So basically now I'm going to write the fraction for the rates. So the 1/2, the change in H plus over the change in time. So you have to write both halves of the fraction, just knowing this does not give you the answer. For the NO2, again, it's positive. It's 1/2. And then the change of NO2 minus over the change in time is equal to, this one's negative, and it's 1/3. Hold on, I gotta have my eraser. 1/3 the change in O2 to the change in time. And so that would basically be the answer to this question. Okay? And I can do this for, I could have done this for ammonia and for water also. I can do any reactant and or any product. Okay, let's go to another one. I suggest pausing the video and doing this one on your own, although it's a little bit more difficult. Okay, so it says that when magnesium is reacted with dilute hydrochloric acid, a reaction occurs in which hydrogen gas and magnesium chloride are formed. First thing I have to do is write a balanced formula. So magnesium is just magnesium, Mg, is reacted with, so that means it's plus HCl. And then to form H2 plus magnesium chloride. And so then I have to balance this, and the only thing I have to do is balance is this. Okay. And so it tells me that the rate for magnesium is 5.0 times 10 to the minus 9 moles per second, and they want the rate of consumption of HCl. Okay, so now we're relating these two. So it's going to be a negative change in concentration of magnesium per unit time is equal to a negative 1/2 the change in HCl over the change in time. So I'm going to have a negative 5.0 times 10 to the minus 9th. Actually, it's already moles per time is equal to negative 1/2 of the change in HCl per change in time. So I'm going to multiply both sides, or divide both sides by negative 1/2, or I can multiply both sides by negative 2. So 2 times that is going to give me 1.0 times 10 to the 8th moles per second is equal to the change in HCl over the change in time. So if you think about it, it makes sense. The HCl is being consumed at twice the rate that the magnesium is being consumed, because for every 1 magnesium, it takes 2 HCl's. Okay. Here's one more. This is back to no math. It says catalytic converters and combustion. Catalytic converters in automobiles combat air pollution by converting the NO, nitrous oxide, and carbon monoxide into nitrogen and carbon dioxide. How is the rate of formation of nitrogen, so this, relate to the consumption of carbon dioxide? Okay, so we're just doing the relationships now. So this one is a product, so it's positive, and there's no fraction because the coefficient is 1. Or you could write 1 over 1. Okay, this one's negative because it's a reactant, and the fraction is 1/2. Okay, so it doesn't to me matter which order you put them in. So I'm going to have the fact that it's going to be the change in concentration of N2 over the change in time is equal to negative 1/2 the change in CO2 concentration per unit time. And that's all you have to do for that one. And that is the end of this video.